Okay, so now that we have gone through our folder setup and we've got our dependencies installed, and you should see them because now you should have your node modules file, which you can actually see over here. And if you open it up, you're going to see a lot of different packages. Now these are standard packages that come with React. And but also in addition to these, we're going to have the dependencies that we have added in order to get our smart contract stuff working with the Truffle framework. And of course, and our Web3 and all that stuff. Okay, so let's get into setting up a bit of code so that we can actually configure our Truffle dependencies to be working and executing smart contracts and building the right directories and everything. So in order to do that, we need to create a Truffle configuration file. Okay, so what we're going to do is actually go into the main folder. You don't want to put this Truffle config in your source or in your public. You want to put it in the main folder because that's where Truffle will be looking for it. And we'll create a new file, and it's going to be called truffle -config.js, like that. Okay. And this is a JavaScript file, which essentially is going to, what we're going to do is hook up to our Ganache, right? We have to have our Ganache opened up. So you should have your Ganache set up over here with your addresses. And we're going to hook up to the Ganache network with the network ID. And we're going to use the RPC server. So we have to set all this configuration up in here. So the first thing we want to do is we want to require our Babel. We want register, and so this is so that we have our Babel, and we're going to also want our polyfill. So we got that and our polyfill. And I'm going to go ahead and make that a bit bigger for you. And of course, we need our semicolons here. Oops. Okay, and now we want to export. So we're going to make a module.exports, and that's going to be an object that's going to take our network. Development, okay, and we're going to have host, we're going to have a port and network ID, port, post and network ID. And to get our host, we're going to go back to our Ganache, and our host here is this number. We want to use this number. All right, so this is where we're hosting. And we want to use commas here. Host, our port is our port number, and that's going to be port number, and that's going to be standard 7545. And remember, this needs to be a string as well, because this is going to be read out as a string. And our network ID is basically we want to connect to any network, and we can do that with using the asterisk. And we can even put a comment here, connect to any network. Okay, and we can insert some commas here. Okay, so what did we just do? Well, essentially we are creating our export over here, and then we're setting up our networks to the Ganache network, okay? And then the ID of the network is going to be to whatever the network is, but we have our port set up to Ganache, and it's being hosted over here. Oh, and wait a minute, I just realized that this is actually the port number right over here when I copied it over from Ganache. Okay, and so now what we want to do is we want to create our contracts directory so Truffle knows where those are, and we can do that _directory. And that's going to be in our contracts, essentially, in our source, right? So in order to get there, in our source. So in order to get there, what we want to do is we want to go into the source file first, right? And then go into our contracts. That's where we're going to find that. So we're going to do src contracts. Okay. And then what we want to do is we also want to be able to build our directories for our JSON files. Because remember, we are writing our contracts in Solidity, but then we're building our application with JSON and JavaScript. We need to have our JSON files spat out. And so where are we going to be spitting out and building these directories out? Well, we can create that right now. So we're going to actually create a file folder for that. And let's do that. So contracts _build _directory. Okay. And here we're going to do this. We're going to create a file. We're going to create a file in our source. So actually go to your source here and you can click new file. And we're going to call this oops, sorry, not a file, my bad. We're going to create a folder. So right click, new folder, and I'm going to call this Truffle dash. And we're going to say ABIs because remember our JSON will be spitting out the ABIs as well as the address information for the smart contracts. Now, if you don't know what that is, we're going to see it in action, so don't worry about it. But essentially, it's where we're storing all of our JSON, which is what we use for our smart contracts in order to gain access with it with JavaScript. Okay, so Truffle underscore ABIs like that. And now we have this folder set up so we can actually go to it. That's where we're going to be building out the contracts. So we'll do SRC, oops, SEC. Nope, we don't want the SEC involved with this just yet. We're going to steer clear with the Tether and SEC, not the best combination apparently, right? So SRC dash Truffle underscore ABIS. Yes. Okay, and then we are going to want to have our compilers set up. And our compiler is, of course, with Solidity, Sol-C, and we're going to want to put in our version. We're going to say enabled and Sol-C. Okay, and we're going to have a version, and we're going to put anything above, that's what this arrow is for, 0.50. So anything above this version is fine, and we'll have a little we'll have our optimizer set up here. And we can say it's enabled. We'll set that to true, and we're going to run 200. Okay, and I'm going to save this. And okay, essentially this is it for our Truffle configuration. It's a basic configuration here. And just to review what we did, we bring in Babel, and then we export our modules here. So we have our networks exports so that we can export the code, and we set up our network to Ganache with the host and the port. And we use this asterisk to match it to any ID. This is similar, and if you build things out server-side with Express, then you'll see the similarities here. And then we also have our contracts directory of where we want our contracts for Truffle to be seeing that. And we have our contracts build directory, which is our SRC Truffle ABIs. So Truffle ABIs over here. We have our compiler set up to Solidity. Any version above 5.0 is fine. Or 0.50, sorry, and we've also set up a little optimizer that's running at 200, which you don't have to worry about for now. And that's it for setting up the configuration. So in the next video, what we're going to do is we're actually going to build out a migration contract, and with that we can initialize our migrations, and then after that we're going to build out together our first smart contract for this project. So great work coming through this. So great work following along up to this point. If you're not sure about this configuration and what this stuff really means, don't worry, we're going to see it in action, and it's going to make a lot more sense once we start deploying smart contracts to the blockchain. Okay, see you in the next video. Okay, so we've got our dependencies installed, and we also have our Truffle configuration so that we can be building out and deploying these smart contracts. Now let's go ahead and actually set up our migrations contracts so that we can make these updates to the blockchain when we're building out our smart contracts and deploying them to the blockchain, okay? So what we want to do first is we want to go into our contracts folder over here, and let's go ahead and make a new file. And with a capital camel case here, we're going to go migration. We're going to call it migrations.sol. Okay. Now inside our migrations.sol file, we're going to bring in, the first thing we're going to do is bring in Solidity. And of course we do that by stating pragma, Solidity, and then the version. And we're going to use any version above 0.5.0. Okay, and now we can actually, remember that Solidity is a static language, so you have to define your terms in many cases, define your variables, what they are, define the global, local aspects of them. You have to state everything explicitly. So what we want to do for contracts, for example, is we state that it's a contract. And we're going to do that here by actually typing in contract. All right, so this is how we write our contracts, if I can spell contract. Okay, contract. Okay, what's wrong with my brain? Yeah, contract, and so it's going to be a contract. We're going to call it migrations. And once we insert the object, we see already that it's recognizing that it's a contract for migrations. So our Solidity extension is working. Okay, and we're going to do address, public owner. Okay, and uint last completed migration. And we're also going to set this to public. And I'm going to explain what this is. Okay, so what are we doing here? We're setting up our smart contracts. So we're setting up an address. We're making it public, meaning that it has access here outside of the contract itself if we want. And we're setting this to owner. So we have our owner address. We're creating also an integer here. And we're not specifying the type, but we're making it public, and that's going to be our last completed migration, right? So that's how we're going to be keeping track, essentially, of each migration with this integer, and we're going to need the addresses. So hopefully that makes sense so far. Okay, now we're going to bring in the special constructor, and here we're actually going to set our owner to our message sender, message.sender, and our constructor is going to be public as well. And message.sender essentially is just the current person who is doing a call with Solidity. And what do I mean by that? Well, it's the person who is currently connecting with the contract. And we want that to be, of course, the owner for our migrations. We want to be using our owner address. So we're the ones, so we're checking to see that it's the owner address for these updates to be happening, and we're setting it, of course, to that. And having our constructor set up means that now we can create a new instances of this. This is why we don't, this is instances of this. So we can set this up as an object now by having it in our constructor, doing it this way, which is really important for when it comes to deploying and setting up our JSON to deploying our contracts, as we're going to see. So if this constructor thing is confusing, don't worry. We use the constructor a lot in React and in JavaScript and in coding language in general. It has now in Solidity, we can actually create these modifier functions, and modifier functions are what they're called essentially, is that they can modify your functions. And we do that again explicitly by stating modifier, and we're going to put a restriction. Sorry, not restriction, restricted. And we're going to say, if message.sender equals owner, if I can spell it, underscore. Okay, so what is that? What did I just do here? Well, I created a conditional statement, if, and what I'm saying essentially is that if message.sender is equal to the owner, okay? So if the person who is currently calling out for the contract is the equivalent of the owner address, okay, then if this is true, right, because this is implicitly true, it's set to true as a condition in the if with JavaScript, and Solidity does the same thing because it's very similar to JavaScript, then we underscore. What does underscore mean in Solidity? It just means continue with the function. So if it's true, continue. And by default, if not, it's going to send out an error. All right, it's going to send out an error. So it's not only going to send out an error, it's going to stop it from continuing as well. So this is our modifier in order for this to continue. Okay, and now we're going to have two functions that we're going to set up for our migration. Two functions that we're going to set up for our migrations contract. We're going to have one function that's essentially going to set the completion to each contract, and then one that's going to upgrade the contract. Okay, so how would we do that? Well, we can just write out our functions in Solidity by typing in function, easy as that, and we're going to do set completed. Okay, and this is going to take a uint. It's going to take an integer completed, and we're going to set it to public, but we're going to make it restricted. And what are we going to put in terms of our logic in here? Well, what we're going to say is we're going to say the last completed migration is going to be equal to completed. Okay, to completed. Okay, so what do we just do? So we create a function in our contract that essentially is set up to public, but we add this restriction, the modifier. So we're adding the restriction, and the restriction is, of course, to check to make sure that the message sender is equal to the owner. So we're only going to run this function if this is true. Okay, then we get to continue. Right? This is how we do this in Solidity. And then what we're going to do is we're going to set the completed to the integer of the last completed migration, every last completed migration to completed, which is our integer in this function. All right, and now that we have this set up, we can set up our upgrade function. So we're going to make another function, upgrade, and we're going to do, this is going to take the address, which is going to be the new address, right? Because we're upgrading every time. And again, it's going to be public and restricted. I know that might seem a little bit like an oxymoron, but they mean different things, right? Public access. This is our conditional statement. And what's the logic that we want to put in our upgrade function? Well, what we want to do is we can bring in the migrations, and we're going to set up this thing upgraded. Okay, and now we're going to set our upgraded variable here to migrations, but with the new address. Okay, and now upgraded is going to actually run the set completed function. So upgraded.set completed, and what's it going to take? Well, I'll let you think about it. What do we want to put? We're upgraded.set completed, and it should take last completed migration, right? Right? So if you guess that, then amazing, you're getting this. If you didn't guess that, really no worries, because honestly, this is quite abstract. We can't actually. We're not actually running any tests. We're about to run some tests. I'll show you how to do this in the Truffle console so you can actually see how this operates. But so far, this is a lot of just kind of understanding with just your understanding with just your thoughts. But really, this is all we need right now for our migrations. Like, this is all it takes. It's really not that. It really isn't that bad. If you're new to Solidity and new to JavaScript, it could be a little confusing for sure, 100%. So let's just review it together, what we just did here. So we bring in Solidity and we created our contract migrations, right? What we do is that we create our public owner and we set that to the address. Okay, we create our integer last completed migration to keep track of essentially each migration. We have our constructor for our objects. We have our special constructor function here, and here we set our owner to the message sender. So it's to the person who is currently opting for the contract. Okay. Then we have a modifier. Okay, so we have this modifier that we use a few times. So it just makes sense. So it's just refactored instead of just doing this twice. So this is just a type of refactoring in a sense, because you see how we are able to use this. We have a simple logic over here with an if conditional statement saying that we have to make sure that message.sender is the owner. Okay, that's the only way we can continue running these functions, and we do that with the underscore. All right, and then lastly, we have our functions that essentially execute the updating and the updating or the upgrading to the new address. Essentially, you can say update or upgrade. Essentially, it's an update, but it's like an upgrade, however you want to think about it. But we have our set completed function, which then takes the unit completed. We put in our restriction, we set it to public, and then we set essentially what each integer is to this last completed migration. And now that we have this set up in our upgrade function, now we can actually run our migrations to the new addresses and then set them to each last completed migration here. Okay, so again, we're going to see this once we actually start updating in our application, in our yield farming contract, because we're going to be developing several different contracts and then having these contracts interact with each other. So this is going to be very powerful, and it's essential. We can't actually do this without having our migration set up. So great work going through this step by step. And in the next video, what we're going to do is actually set up our first smart contract. So we're going to go into our migrations folder and create some logic and create the logic it takes for our initial migrations, and then build out our first smart contract and see some deployments in action. Okay, great work. I'll see you there. All right, welcome back. Okay, so now that we have our contract migration set up, like the contract for it, what we can do next is we're just going to set up a file that will execute so that whenever we're deploying our contracts, we run the contract migration script as well. And that allows us to update our addresses whenever we want to make modifications and see our modifications to our smart contracts. Okay, so how do we do that? Well, we want to go to our migrations folder at the top here, and we're going to create a new file in our migrations folder. New file, and we're going to call it run_migrations.js. Now, once we're in our oops, let me just close these. Make sure we save. Config, JSON. Okay, so what is the first thing that we want to do in our run migrations file? What do you think is the first thing that we want to do? Well, the first thing that we want to do is, of course, we want to grab our contract. We want to grab this migrations.sol contract. So how do we do that? Well, we do that by creating a constant variable over here. We're going to call it our migrations, okay? And then we're going to set this to require.artifacts. Oops, wait, I did that the wrong way. Sorry, artifacts. It's not required artifact. Artifacts.require, and we're going to get, I don't know what's wrong. My brain is backwards today. All we have to do here is just require the migrations. And we don't actually have to set where, because we have our configuration, remember, which knows that it's in our contracts. Our contract directory is over here. So we can just grab artifacts.require, and we grab our migrations like that. All right, and now we're going to set up a function, and we're going to export the function. So we're going to do module.exports. So we export it, and it's going to be a function, and we're going to call it deployer, because this is what's going to deploy the migrations effectively so that we can deploy the smart contract. And it's very simple, the logic that we're going to add here. What we're going to do is we're going to set the function deployer to deploy. Okay? And what we're going to be deploying is our migrations constant variable over here. And that's it. That's pretty much it. This is what it takes with JavaScript in order to make updates to our smart contracts. We find a way to do this by updating the state of the transaction, so to speak. Okay, that's a way for you to think about it. So, and what did we do, and how did we do that exactly? Well, let's just review very quickly again. Well, we have our migrations.sol file over here, and we created some functionality here in order to upgrade and keep track of the upgrades and to hook that up, to wire that to the owner, make sure that it's the owner. And once we have that up, we have our configuration to find that and export it, and then we can use the deploy functionality in a function that we create called deployer, and we set it to that contract, the migrations contract that we created. Awesome. And now that we have this done, this very simple couple lines of code, we are effectively able to now migrate our contracts. We have our development contracts, and we have our entire environment set up now. We can finally start writing out our smart contracts. We're good to go here. So excellent work. If you understand how some of these things are working now and how we can be interacting with Solidity and JavaScript with each other, and you're starting to get a sense of this, then that's amazing. If not, and you're still really confused about this initial code and what we've written out so far, really, honestly, don't feel bad about that. Don't be too. I promise once we start writing out some code for our contracts in the next couple videos, things are going to really start to make a lot more sense, because we're going to start to see these things up and running and in action. We're going to be able to keep track, and we'll be able to verify these transactions with our console and Ganache and our addresses and everything. Okay, so that's it. Don't forget a semicolon down here and hit save, and I'll see you in the next video. Let's develop our first smart contract for our yield farming app that we're going to be using in order to store our Tether. So remember that this is a yield farming application in the sense that we're going to create an application that's this digital bank. So what we're going to do is we're going to have some Tether. So when you use the app, you have about a balance of a certain amount of Tether that the customer gets to use or the investor gets to use, and then they can stake. They can deposit it into our bank. They take that amount that they have, they could deposit it, and when they deposit it into our bank, we give them a reward. We reward them for depositing it. Okay, and this is a very common type of functionality in tokens with DeFi and yield farming. So it's cool to kind of see how this works. And, it's also very basic in banking with interest, right? It's like a saving account. You put money in, you can create interest, a return, you can create lending, rewards, all of that. So we're doing that in a decentralized form. So let's make our first contract, which will be the Tether. And remember, what is Tether? Well, as we can see here on Investopedia, Tether is basically a blockchain-based cryptocurrency whose crypto coins in circulation are backed by an equivalent amount of traditional fiat currencies, so the dollar, the euro, the Japanese yen. Okay, so what does that really mean? Well, it's basically just a stable coin, meaning that it's going to have a backing that creates it on blockchain, but it has an equivalency to what the dollar does. So it remains stable. That way it's very, very useful when it comes to trading in crypto, because if you want to keep your currency in a stable currency when you're buying and selling, let's say Bitcoin and Ethereum, having some Tether on hand or having something like DAI or a stable coin to depositing, investing, exchanging. And so Tether is generally traded under the USDT symbol. And actually Tether is under a lot of scrutiny. But all that being said, Tether is still extremely widely used in crypto. And you can trade it, on Binance, Gemini, CoinSpot, Kraken, etc., etc. Okay, so we're not actually creating real Tether here. What we're doing is creating an emulation, a version of Tether. It's sort of a mock Tether, just like what Greg did for MDAI. We're reverse engineering his app, and we're going to be just switching it up just to be fun and go with Tether instead. Okay, so what we want to do is... Okay, so enough with the chit-chat. Let's actually start building out this contract. So what we want to do is go into our contracts folder again, and we're going to create a new file, and we're going to call this file tether, .js. Oh, wait a minute. Mistake. Can you catch the mistake I just made? Well, we're building our smart contracts, so what is wrong with tether.js? Well, JavaScript, nope, is not going to cut it for what we want to do. We want Solidity. So we're going to rename the file tether.js to tether.sol. Okay, and now that we've properly named the file and the data type, what should we do first? Well, you probably guessed it. We're bringing in, oops, if I can spell it, Solidity. So we're doing our usual thing here. The uptake 5.0. All right. Oh, wait, and I just realized we do not want to be turning this into a string. We're actually typing in the language. So I'm going to remove that. And I think I actually did that in the migrations as well. So if you notice that error, you want to go back to your migrations.sol and remove the string that I had here. So let's get rid of that. Okay, so back in our Tether file, tether.sol, what we want to do is create a contract. Okay, and we're going to call this Tether. All right, and this is our contract Tether. This is the skeleton. So what do we want to put in our Tether? Well, for now, what we're going to do is we're just going to build a very basic shell. We're not going to give it really any functionality, but we're going to define some static terms for Tether so that it has a little bit of personality. So we're going to give it a name, okay? And this name is going to be called Tether. We're going to give it a symbol, and the symbol will be USDT, right? We are going to give it a total supply, and the total supply is going to be 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I'm just going to put in a comment here, and I'm going to write 1 million tokens. Okay, and I'm going to explain that in a second because this total supply is actually 1 million. I want Tether to have 1 million tokens. But as you probably guessed, this number does not equal 1 million, right? I think there's a little too many zeros. So I'm going to explain how this works in just a second. So just bear with me for now, and we're going to get to how this actually works in Solidity. So I'm going to add also decimals. Now remember, because this is a static language, again, we have to declare what these variables are. So this is a string, right? Public tether is a string, so we're going to write string public. Sorry, tether is a string, so we're going to write string public. We're making it public so that it can be accessed by other contracts as well. We're going to do the same thing for symbol. It's a string. Now is total supply string? No, it's a uint. And we're going to use 256. We're also going to make it public. And we're going to also we're going to do the same thing here, uint 8. And since we're using Solidity and not JavaScript, we have to remember to put in our semicolons. Little semicolon action over here, over there. That's not going to do it because that is not JavaScript. Okay, there. Okay, so why do we see so many zeros here after the 1 if we're going to say this is 1 million tokens? Well, actually, this isn't even 1 million tokens. This is only going to be 1 token, as a matter of fact, because I only added 18 decimals. Whoa. Clarian, what are you talking about? 1 token, 1 million? Is it like a trillion? What is going on over here? Okay. Well, this is actually quite simple. For example, with the US dollar, we know that when we think about the US dollar, we don't think about, oh, if you want to buy a chocolate bar, that's going to be 1.04238, whatever, blah, 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 987 with like 18 decimal places, right? We don't do that because imagine every time trying to find the exact amount of change before we had debit, etc. And just even with debit, do we really care about fractions and fractions of pennies when it comes to the US dollar? Well, the answer is no. Generally, your average retail customer and investor, no, they do not care about what's going on the 18th decimal. Maybe big corporations, that's a whole other story. But we're talking about big institutions and big corporations, that's another story. But we're talking about your average Joe over here, including myself. I do not care about this 0.00. But now, when it comes to cryptocurrencies like Ethereum, DAI, and Tether, of course, they generally do care about the decimals. And they have, Ethereum has 18 decimals. So because of that, when you talk about Ethereum in a transaction, you're going to see something like 1 Ether, but 938, so forth. And these numbers actually do matter, especially when it comes to the fractionizing. Not fractionalizing, sorry, I said fractionalizing before, but this is fractionizing of the fractioning or the fractionizing, I don't know. Hopefully you get the gist of what I'm saying here. So actually, the reason why this is only 1 token is because we've added the 18 decimal places with the zeros, right? Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, 1. So if we want this to be 1 million, what should we do? How many zeros? What should we do? What should we do to this number? What do you think? Well, if you guess we should add the amount of zeros to make it equal 1 million, then you totally understand. Then you get this. Congratulations. If not, don't worry. We're going to actually see how this works when we're depositing these numbers. But yes, in effect, now if I add a 0, now we have 10 tokens. Now we have 100, 1,000, 10,000, 100,000, 1 million tokens. Okay, and here we have our very, very basic contract, which has 0 functionality. We can't transfer anything. We can't transfer from anything. We can't approve anything. But we do have a name for our contract. We do have a total supply, and we do have a symbol for it. And we've created the decimal places, which are the fundamentals for any smart contract. So let's go ahead and save this and actually deploy it and see if this contract is. So in order to deploy it, what we want to do is actually create our deployment script. We haven't done that yet. And we're going to put our deployment script next to our migrations. So we're going to put it in our migrations folder, because essentially our deployments are all going to be migrations. And hopefully that's starting to make sense. And hopefully that's making sense for you. So in the migrations folder over here, we're going to create a new file. Here we're going to create a new file. Oops. And we're going to call this deploy underscore contracts.js. All right. So we've got a JavaScript file over here. So we've got a JavaScript file over here where we can set up here where we're going to deploy our Tether, our first contract. So what's the first thing we should do? Well, just like with the run migrations one, we need to bring in the actual Tether contract, right? And we can do that here. I'm just going to go into the migrations and copy this. You know, we're going to take the whole thing. I'll just copy this and paste it in here, save some time. And we're going to rename this to constant tether, right? Artifacts.require, and we're going to take tether. And we're actually just going to make this an anonymous function that runs our deployment. And we're going to make it async, and it's going to take an argument of, what do you think the argument should be? Well, it's going to be the deployment, right? And so as we can see, this is very similar to our run migrations. The only difference is we're setting it to tether. And do you notice anything else? Well, we've actually created an async function. And what is an async function in JavaScript? Well, essentially, async allows us to run our JavaScript code asynchronously. And what that really means is it's just in the sense where we set up our functions to send out a promise. JavaScript is going to run synchronously. It's going to run down. We know that it just runs, and that's how it works. You know, it's not multi-threading and running a bunch of things. It's running down JavaScript. So how can we get it to wait for things to happen before it should move on? How should we get it to wait for code to execute? How can we get it to wait for things to return, like when we're fetching, API, or when we're fetching things that necessarily aren't going to come right away or come in time for we want time, which will cause our code to crash? Well, what we can do with JavaScript is use this very, very powerful tool, and is essential when it comes to especially working on JavaScript on the web with JavaScript, when it comes to waiting for information to process, the async await. And I really do encourage you to look up async await if you've never heard of it and this is confusing. Honestly, it's confusing for pretty much most developers, to all developers. The first time you hear about it and you're learning about JavaScript, you can be like, especially if you're just starting and coding in general. But really all it means is just to think about it as something that is waiting. And that's why we have the word await, that we don't want it to deploy until we have all the information that we need to deploy Tether. And this is really important with the blockchain, right? Because we need that information. And just like that, hold on. Let me just tell you what we just did here, because you can get a little bit excited. I know we didn't write that much code in our Tether contract or in our deployment contract yet, but it may feel that way, but we have effectively created our entire environment. So let's go ahead and deploy it now and test out a deployment, see if we didn't make any mistakes in the code. Hopefully, fingers crossed, our Tether contract can be deployed successfully with everything that we've built to do so. Okay, so the final thing that we want to do for Truffle here in order to deploy our Tether Solidity contract is that we're going to want to name our migrations.js files so that they matter and match with what Truffle.js expects, or what the standardization would be. So basically, the run migrations file where we actually run our migration and deploy that is the initial one. It's going to be checking that. Then we do our deploying. So we're actually going to rename run_migration or run-migration to one_initial_migration. And deploy contract is the second step. So we're going to rename this to _deploy_contract. And there's actually one last thing we want to do. Let's go back to our migrations.sol, and we're going to rename setCompleted underscore to setCompleted set camel case completed, like this. And we're going to do the same thing over here, upgraded dot set completed. Now, why are we doing this? Well, here's the thing. What we're doing here essentially is that we're setting up the contract migrations ourselves manually. But what we could have done, actually, instead of writing everything from scratch, I know we could have saved some time doing this, is back in the terminal, we could have actually just, here, let me just make a new tab. Back in the terminal, we could have actually just run truffle initialize. And this actually would have initialized our Truffle configuration file. It would have initialized our initial migration, but I thought it would be interesting to actually write it all out and go over the logic together, so it's just this default. But the reason why I'm stopping now and coming back and changing the set completed, it's to show you that even though we can write out this, what's actually happening here is that Truffle, when we run Truffle migrate like we're about to do after we compile, it's going to search for the default. So it's actually going to search for set completed like this, camel case. So if we were to write this out ourselves, we have to be careful. We have to be careful that we write it out in a way that Truffle migrate can find it. So it's not going to be able to find set underscore completed, just like it won't be able to find certain other files when it's looking, because it's looking for a specific set of information. All right, so that's the last thing. I just wanted to show you that. So make sure to change it to set camel. We're ready to go ahead and compile. So we're going to go back to our console, make sure that we're in the DeFi staking app. And the first script that we want to run is truffle compile. And this is going to compile our contracts. So let's hit enter. Okay. Now after this, we're going to run truffle migrate, and we're going to do our first migration. Okay, so let's take a look at what we see here. Well, we see the initial migration JS, and you may not, and we have our deploy contracts as well. All right. And so we see that we should have a cost for ETH, so that if you successfully deployed this now, if you go into Ganache, you should see that your balance has gone down. Now my balance has been going down because I've been using this account for various other things and testing out the course. And we see that we have our Tether up here, and there's a contract address created for Tether as well, ending in 3460. So this is actually our smart contract address. We have our block number, we have a timestamp, and we have the account number that it was deposited from for the transaction. And this account number, you see that ends in 051CA. If we go into Ganache, matches here, 051CA, the address. It matches the first address, which is what we're setting to the owner. So this means that we have successfully, so yours should be matching your account if you check it out. And if you're seeing this and it matches, then congratulations, because we've successfully compiled the first part of our smart contract. Now I know it's just a shell, and there's nothing really in our Tether, contract yet besides the total supply and the name and symbol, but we're going to keep on adding to it. And additionally, another way for us to actually test and see that we're up and running with our smart contracts on the blockchain is by using our Truffle console to interact live with our smart contracts up on Ganache. And we can do that actually by here. We create a new tab in our console and we can run Truffle console. And this is going to load us into a console mode where we can actually fetch information and data from the blockchain. So what I'm going to do first here is I'm going to set Tether equal to await. So remember, it's the blockchain, so we have to wait for the information to process here of camel case Tether dot deployed. And we're going to receive undefined because that's just what it's sending back. But don't worry, we set up to the deployment of our contract Tether, so that if I call Tether now by typing in Tether, and there you go. So let's take a look. Here we see our Tether. Here we see all of our information for our tether. Now there's a lot on here, I know, but we can call upon different information using JavaScript. If we want to get the name of what tether is, for example, instead of searching through here, we can just do tether.name and we can actually call the function. And we see the name, mock tether token. And if I go back to Visual Studio Code and I go to Tether, to our contract, Solidity, we're going to see name mock tether token. And there's something else that you should notice before we conclude this video. And maybe you noticed it already, but if you haven't, if you take a look on the left side, you're going to see that we have a new folder. And what's this folder? Well, this is the Truffle ABIs. Remember, in our Truffle configuration, we set up our contract to build the directory to the Truffle ABIs. And what this is our JSON. So we've got the migration JSON of our contract to migrate and update information. And we have our tether JSON, which we're going to be also leveraging for our front end, for the front end part of our building for this application. So this JSON was spat out when we compiled down and migrated our smart contracts on the console. And every time that we change our contracts, our JSON is going to be updated when we recompile and upgrade the information accordingly. Okay, now here's an exercise for you to try to figure out. Go ahead and try to use the console to get more information from your tether. Well, if we go back into our contract, we see that I've gotten the name. See if you can figure out how to get the symbol total supply. All right, that's it for now, and I'll see you in the next video. Bye.